Hello. So this is lesson 6.3, matrix operations and their applications. Now, at any point, just like in the previous videos, if you need to pause and, you know, restart again, feel free to do so. So we're first gonna start by talking about notations for matrices. So an array of numbers arranged in rows and columns and placed in brackets is called a matrix. We can represent a matrix in two different ways. Um, we use a capital letter, A, B, or C, that denotes a matrix, um, or a lowercase letter enclosed in brackets. Um, Now, a general element in matrix A is denoted by A sub ij, and this refers to the element ith row and jth column. So a matrix of order, and this word should not be there. So a matrix of order M by N has M rows and N columns. If M equals N, a matrix has the same number of rows as columns and is called a square matrix. Okay, let's look at an example here. So we have a matrix notation here. We've got matrix A. Now the question is, or first question is, what is the order of A? So matrix order M by N has M rows and N columns. So M rows, this has 1, 2, 3 rows, 3 by, and it has 2 columns, 3 by 2. Next, we're going to go ahead and identify the element A sub 1, 2. So element A sub 1, 2. 1 is the row and 2 is the column. And that's always how you do it. It's first the row and then the column. So we have first row and second column, which means that this element is -2. Okay, next one is a 31. Again, 3 is the row and 1 is the column. So third row, first column, this is 1. Okay, equality of matrices. So two matrices are equal if and only if they have the same order and corresponding elements are equal. Um, Now, definition of equality of matrices. Two matrices A and B are equal if and only if they have the same order M by N and Aij equals Bij for I equals 1, 2 all the way to M and J equals 1, 2 all the way to N. Next, we're going to look at matrix addition and subtraction. So when we are adding or subtracting with matrix, we are adding the elements in corresponding positions. So you can see, like, for example, 1 plus minus -1, -2 plus 6, and so on. Same thing with the subtraction. Um, we are subtracting the elements in corresponding positions. So, okay, let's look at adding matrices here. So again, we need the corresponding elements when we are adding. So negative 4 plus 6 is that first um, row, first column. So negative 4 plus 6 is 2. Next one, we're going to take the second row, first column, 7 plus 2, which is going to be a 9. And then first row, second column, 3 plus negative 3, that's a 0. Negative 6 plus negative 4 is going to be negative 10. And that is our matrix when we add. Okay, this next one is going to be a subtraction. Same thing, we are subtracting corresponding elements here. So our first row, first column is going to be 5 minus negative 4. We're staying in the first column. Second row is negative 3 minus 6. Third row is 0 minus negative 5. Second column, first row is 4 minus 8. Second row, 7 minus 0. And third row, 1 minus 3. Okay, 5 plus 4 is 9. Negative 3 minus negative 6 is negative 9. 0 plus 5 is 5. 4 minus 8 is negative 4, 7, and negative 2. And that would be our matrix after the subtraction. Okay, let's look at properties of matrix addition. So we have A, B, and C are n by n matrices, and 0 is the n by n 0 matrix. And then the following properties are true. So A plus B equals B plus A. That is our commutative property of addition. When we switch the parentheses, so in the on the left, we've got A plus B inside parentheses plus C, and that does equal A plus, and now B plus C inside parentheses. That is the associative property of addition. And when we are adding a 0 matrix, so A plus 0 equals 0 plus A equals A, that is the additive identity property. The identity does not change. And then when we're adding the opposites, so A plus negative A, that equals negative A plus A, that's going to be a 0. That is the additive inverse property. Okay, next we're going to define a scalar multiplication. So if we have matrix A, and that's a matrix of order n by n, and C is a scalar, then the matrix CA is the n by n matrix given by. So this means that we are multiplying each element by C. So this matrix is obtained by multiplying each element of A by the real number C. We call CA a scalar multiple of A. Okay, so let's see an example. So we have matrix A and we have matrix B, and now we need to find negative CB. Okay, so negative C is going to go outside, and our B matrix is negative 1, 8, negative 2, and 5, and we are multiplying each element by negative 6. So negative 6 times negative 1, negative 6 times 8, negative 6 times negative 2, and negative 6 times 5, and this is our new matrix. Now we do the multiplication, and we get 6, negative 48, 12, and negative 30. And that's it. Okay, next one. We are still doing, or the next example is still scalar multiplication. Now we are finding 3a plus 2b. So 3 times a matrix A plus 2 times matrix B. Okay, so let's multiply each element of matrix A by 3. We get negative 12, 9, 3, and 0. And then each element of matrix B by 2, negative 2, negative 4, 16, and 10. And then we are adding, remember we're adding the corresponding elements. So negative 12 plus negative 2 is negative 14. 9 plus 16 is 25. 3 minus 4 is a negative 1. And 0 plus 10 is 10. And that would be our answer for 3A plus 2B matrix. Okay, now we're going to look at properties of scalar multiplication. So again, A and B are M by N matrices and C and D are scalars. Then the following properties are true. So we can do C times D inside parentheses and then multiply that by matrix A. Or we can multiply first D times the matrix A and then multiply that by C. This is the associative property of scalar multiplication. Or 1 times matrix A is the same thing as the matrix A, and this is the scalar identity. Identity doesn't change property. Okay, next one, we have C, and then we've got matrix A and B inside parentheses. We can multiply C times matrix A and then add C times matrix B. This is the distributive property. 4 is just all, or now we've got the scalars C and D that we are adding first and then multiplying by matrix A. Or we can do, it's the same thing as C times matrix A plus D times matrix A. Well, what we're doing here is we're distributing again. So this is the distributive property. Okay, let's look at an example here. Solve for x in the matrix equation 3x plus a equals b. So 3x plus a equals b. So what we're going to do here is we're going to solve for x first here before we plug in the matrices. So we're moving a to the right. So we get 3x equals b minus a. We are dividing by 3. So x is going to be 1/3 b minus a. Like this. Okay, so we're plugging in now. 1/3 b, and this is inside parentheses, but this is inside brackets because it's a matrix. Negative 10, negative 9, 1, 17. So b is first, and we're subtracting a from b. So we're doing the subtraction again, corresponding elements, negative 10 minus 2. That would be negative 12. Negative 9 minus 0 is a negative 9. And then 1 minus 8. 1 minus negative 8 is a 9. And 17 minus 4 is going to be 13. Now we can multiply this by 1/3 or divide by 3. And we get each element. So negative 12 times 1/3 is negative 4. Negative 9 divided by 3 is negative 3. 9 divided by 3 is 3. And then it's going to be 13/3, since otherwise that's going to be a decimal. And this would be our matrix X that we were trying to solve for. Okay, matrix multiplication. Now, everything that you've learned so far is pretty straightforward, easy. Matrix multiplication requires a little bit more. It's not as straightforward. So the definition of matrix multiplication 2 by 2. Notice that when we are multiplying matrix A and matrix B, what we're doing here is we're taking um, row 1 of A and we're multiplying it by column 1 of B. So A times E plus B times G. So this one here is row 2 and column B. So we would take row 2 from A and column 1 from B. So C times E plus D times G. And then we get row 1 of A times column 2 of B. And then the fourth element is row 2 of A times column 2 of B. Okay, let's do this together. So we're finding matrix A by A times B. So 1, 3, 2, 5 times 4, 6, 1, 0. Okay, so we are multiplying first row by the first column. So 1 times 4 plus 3 times 1. That would be our first row, first column in our matrix. Next, we're going to do the second row, first column. So 2 times 4 plus 5 times 1. Next, we need our first row, second column. So 1 times 6 plus 3 times 0. And then the last one here is second row and second column. So 2 times 6 plus 5 times 0. Again, this is here row 1, column 1. So that is why we took the row 1 and column 1. This one is row 2, column 1. So that is why we're taking row 2 and column 1 from both. Row 2 from the first one and column 1 from the second one. This one here is row 1, column 2. So that's why we took row 1 and column 2. This one, the fourth one, is row 2, column 2. So we took from the first one, we took the row 2, and then from the second one, column 2. Okay, so what do we get as our answer when we do this? So our matrix is 7, 6, 13, 12. Okay, now, definition of matrix multiplication. So the product of a n by n matrix A and n by P matrix B is an M times B matrix AB, whose elements are found as follows. So the element in the ith row and jth column of AB is found by multiplying each element in the ith row of A by the corresponding element in the jth column of B and adding the products. So for the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. Okay, let's look at an example here. So this one is a 2 by 2, and this one is 2 by 4. Number of columns of the first matrix. So the number of columns in the first matrix is 2. Number of rows of the second matrix, that's 2. So these are equal. which means that it is defined. We can go ahead and do the multiplication. So for our first one is going to be its element 1, 1. So that means that we're taking the first row and first column. So first row of the first one, which is 1 and 3, and the first column of the second one. So 1 times 2 plus 3 times 0. This one here is row 2, or let me do. So it's A1, A2, 1. Row 2 and column 1. So it is 0 times 2 plus 0 times 0. So notice here, because this is the same column, those numbers stay the same. They don't change. Next one is going to be row 1, column 2. So we're doing 1 times 3 plus 3 times 5. This one is row 2, column 2. So it's going to be 0 times 3 plus 2 times 5. Next one, oops, row 1, we're still in row 1. Now it's column 3. So 1, negative 1 plus 3 times 4. This one is row 2, column 3. So 0 times negative 1 plus 3 times 4. Again, you want to check that these are the same. And 1 and 3, 1 and 3, 1 and 3, because it's the same row. Okay, next one is row 1, column 4. Row 1, so 1 times 6 plus 3 times 1. Row 2, column 4 is 0 times 6 plus 2 times 1. And now when we do the calculations, we get 2, 0, 18, 10, 11, 8, 9, and 2. And notice that this matrix is 2 by 4. Okay, let's look at this next one. So this matrix is 2 by 4, and this matrix is 2 by 2. Well, 4 and 2, so we've got 4 columns. That does not equal 2 rows. So this is not possible. We would not, if we started it, you could see that we just can't do it because when we're multiplying by, we're multiplying by each of the elements in row 1. Well, we only have 2 rows. We need 4 rows in the second one to do that. Okay. Next one here are the properties of matrix multiplication. So A, B, and C are matrices, and C is a scalar, then the following properties are true. So assume the order of each matrix is such that all operations in these properties are defined. So the first one, we're switching the the parentheses, sorry. So we're first multiplying A times B, and then we're multiplying that matrix by C. That is the same thing as if we multiplied first B and C and then A. And this is the associative property of matrix multiplication. Okay, 2, again, we've got an addition, matrix addition inside the parentheses. What we can do is we can distribute. And it doesn't matter if the matrix that is outside is before the parentheses or after the parentheses. Both of these are distributive properties of matrix multiplication. Okay, next one, we have a scalar multiplication. So we have a C. So on the left, we're first multiplying the matrices and then multiplying it by C. On the right, we're first multiplying matrix A by C and then multiplying by matrix B. Again, this doesn't really, it can be either one. And this is the associative property of scalar multiplication. Okay, then we have an example with transformation of an image. So we have this triangle represented by the matrix 0, 3, 4, 0, 5, 2. We've got this is 0, 0. This one is 4, 2. And this one here is the 3, 5, so the second column. So you can see that here's here are the points. Now, we're going to use matrix operations to move the triangle 3 units to the left and 1 unit down. Now, so our original matrix looks like this. We are moving 3 units to the left. Well, left is the x-coordinate, left, right. So we are subtracting 3 from the first row because that is our x-coordinates. Y-coordinates are the second row, and we are taking them 1 unit down. So we need to add a -1 to all of them. So when we do the addition, we get -3, 0, 1, -1, 4, and 1. So this new matrix here would be, so if we think about 0, 0, we go 3 units to the left and 1 down. It would be right here, -3, -1, which the first row is. Next one, the point 4, 2, we take it 3 to the left and 1 down. We end up in 1, 1, which is that third one. And then we've got 3, 5, 3 to the left, and then 1 down. So we end up at 0, 4. That would be the second column. There it is. Okay, now we have the exact same matrix again. This time we are enlarging the triangle twice its original perimeter. So 0, 0, 3, 5, 4, 2. We are enlarging it twice. So we are multiplying it by 2. So we get 0, 0, 6, 10, 8, 4. So our points are 0, 0, 6, 10 is over here, and 8, 4 is going to be here. So when we do it, we can see that it becomes double its size. Okay, this last one, we are finding B times A. So matrix B times matrix A, and what effect does this have on the original triangle? So our B matrix is 1, 0, 0, -1, and our A matrix is 0, 3, 4, 0, 5, 2. Okay, first row, first column, 1 times 0 plus 0 times 0. Second row, first column, 1, no, 0 times 0 plus -1 times 0. Um, First row, second column, 1 times 3 plus 0 times 5. Second row, second column is 0 times 3 plus -1 times 5. And then our third column, first row, 1 times 4 plus 0 times 2. And second row, third column, 0 times 4 plus -1 times 2. Okay, when we do the calculations, we get 0, 0, 3, -5, 4, -2. So let's see what those are. So our first point is 0, 0 right here. Next one is 3, -5. So 1, 2, 3, -5 is somewhere here. 3, -5. And our third one is 4, -2 right here. So when I graph this, what did it do? It reflected it across the x-axis. Okay, so that's it for this lesson. Let me know if you've got any questions. Bye.